Well, hello everybody. I'm just decided that this would be a cool little project. I'm going to be working on what's called the Game of Life. It was originally John Conway who came up with this. Um, so basically, this is SGELB. They have actually a really good QT rendition of this that uh, they went ahead and used the base of theirs, and I'll be editing that tonight. So yeah, this will be written in Qt5, and just to give you a better idea of what's going on with it, go ahead and Conway's Game of Life. So essentially, it's a cellular automata, uh, and based on a set of rules, it will, yeah, you'll get to watch cells either live or die, and they have a certain life and all that kind of stuff. So my idea with this is basically uh, add some add some fun stuff to it, add kind of a DNA type trait to it, and default behaviors and other stuff, viruses and bacteria and other sorts of things that just just might make it a little bit more interesting. Anyway, as I said before, I'm using the base from somebody else's program. It's actually it's a really cool little simulation here, so I'll be building on top of that. Right now, I'm just basically trying to figure out how this works. And it looks like oh, okay. Okay, that's good. What I'd like to do is try and make this a little less all put into one board class here. I'd like to make it a little more more object oriented, so we can do more fun things with the little cells. So first of all, let's go ahead and just make another cell class just so we can add the fun things that we want to do. In this case, we're going to call it want to another thing, one of the big things that I want to do with this is add a DNA type deal with this. So what I want to do is create a struct that all noobish, I know. But struct and we'll add a. So some interesting things that we could do with this potentially. So you might want something like size attribute, something that tells us the size. We might also want, they're cool. And I'll get into why I want to do this in a struct later. I think this will be really interesting. Had this written. Thought so. Right. Say we do something like age. I don't know, any other suggestions for things that we might want to change in these cells? Obviously this can be changed at another time. Certainly take suggestions. The size is definitely going to have to come later because I'm just going to have to figure out the engine first. Figure out how all that's working. So let's go with movement. this is another big change from the original. I want to give cells the ability to move a little bit instead of basically just appearing and then it either lives or dies. That'll be an interesting. Let's see. Let's do another one called Curiosity. So, this will come into play if we ever get like food or predators or other things involved. And obviously, this is going to take a lot longer than I have just tonight, but I think it could lead to some interesting results. Curiosity would be the percent chance of the cell when it moves, moving toward either food or an unknown object. Intelligence, that would be good. We'll do appearance. So maybe if the cells look significantly different from one another, they wouldn't mate and create new cells. Intelligence would be good. I'm trying to think how I would use that. So maybe it's better at discerning between positive and negative things. I think that would be. Oh, and I can't spell. Okay. Power. So desired. Thanks for the host. Yeah, actually, it really is. This is the first time I've used it in a long time. It's really good, especially for the Qt environment. That's why I decided to do this. This is about the fifth iteration of trying to create this project since I started working on this today. So just trying to get to know the tools is interesting. Let's see, appearance effects. So I hope so too. We'll do another one called tolerance. Uh, effect, but so we could call this smell as well. Um, you know, whatever we would want to say is the limiting factor between cells getting it on, I suppose. So actually, let's I think it makes sense to uncomment these comment things, comments. Anybody know if this has block quote or block selection? That. I don't see blocks. Here's any. Yeah, that's a good idea actually for the bot. Have to work on that as soon as I actually get this up in a repo somewhere. Oh well, I couldn't find how to do the block selection, so I'll just go ahead and I've got to remember how this. We'll call this. These are all going to be shorts, which will could mean I believe a short is 4 bits, but I could be wrong. I might. In fact, I'm probably short. Oh, that's 16 bits. Let's just go with. You know what? A byte should be fine for that. Oh, I'm looking for like the rectangular selection, so I can just like select straight down. I appreciate the that shortcut though. That'll be good to know later. I think I also want another thing that affects behavior, so we'll call that so each cell will have behavior. Uh, Welcome back. We'll have signed So I kind of want behavior to be things that are a little bit more on the learned side of things. Um, so, maybe uh, this cell's parents taught it to, oh, we always move to the west first. So that's what I'm looking. Uh, I want to copy. Definitely want to copy there. Okay. So we could even have something that, well, let's just do an unsigned short. And we'll call so I'm trying to this will eventually will be what's called bit banging these structures. So each cell will have one of these structures, and uh, one of the things in genetic algorithms like this is you can have mutation. So the idea would be that we have a mutation algorithm that runs, and it has a certain percentage chance of changing some set of bits within these data structures, which to the computer just looks like a block of bits. So we'll go through and or those with whatever mutation we come up with. So that's why some of these data structures are a little weird maybe, because we're trying to store a lot of information in as small an area as we possibly can. So what we're going to do is I'll have one called learned we'll do one called learned and one called opinion. And the bit on learned will relate to the bit on opinion. So what we'll have to do is come up with something else, like we'll do an enum or something. This I'm going to change this later, but so we'll call this enum factors. And so what we'll do with this is we'll have like cell, and we'll say that's equal to 0x. So I have these as shorts, which are 16 bits long. We'll just do 0b. For now, we'll do chars because I don't want to think that. We can come back and change those later. But what we can do is do, so a char is 8 bits long. That's standard. That doesn't change language to language. So we can do, say, a cell is, that's 1. It is not happy with that. So then we can say that, let's say a virus, perhaps, so what we'll do here is we'll put that on the next bit up. And what we'll basically just keep doing that until we have all of our potential factors. So we could have another one called bacteria, and that would come to the third bit. Food. That would, I don't know why I copy and paste. So there we have then we have, oh, plan on having another one called poison. And it may come down to needing a short, but I'm not sure. This should be good. We'll call another one painted. That'll refer to food. And could be that some of the food isn't good and they can get sick from it. So you can see that we've pretty well used up that. And what that'll let us do is when we want to find out whether or not something, well, let's just say tech behavior. This will likely be removed later, but you know, I like to show what I'm thinking at least. So this will show whether or not it actually goes towards something. So one thing that we can do is we can see. We'll do if so if we want to check if it knows about food, say, we could do trying to think how this works. We want to mask something out. So it's going to be if behavior dot reference. Honestly, don't remember. Ah, there we go. That looks better. It's been a while since I've used. So if behavior dot, there we go, learned, and then we do a bitwise OR with, let's just go with F as well. Do an OR with factors dot for the life of me, I do not remember how that works. So, look that up. Plus, so if I want to reference an enum, yeah, maybe this. I actually ended up deciding on Ubuntu. I'm on 17.10 right now. Seems to be working like a charm. I haven't had any problems with it. I think I'll probably stick there for a little bit. Let's see. So factors, food. There we go. That's what I'm looking for. So what that'll do is it'll check to make sure, check if it'll check to see if it actually knows what food is, um, and if it does, then it could also check uh, whether it feels like food is a good thing, um, and we can make that be basically 1 equals good, 0 bad. Nice. I don't know. Might have a hard time with Linux distros on that one. And we'll have to cast this to it. That just kind of shows likely what we'll be able to do with it. I'm going to comment this out for now because more of it. And also, don't like putting this stuff in a header file. It goes against everything I believe in. I should have. Oh yeah, that's fine. We have. Oh. Do this IDE. Here we'll just kind of define what these are doing. So a cell Thanks. Is that any better? I hope so. Maybe. Let me know if it's better or worse. Okay. constructs a new cell with random DNA and behavior. Then so this will construct a new cell with inherited DNA and behavior. DNA and behavior are then mutated. So then we'll make, let's see. So I'm going to make two different mutate functions. One that doesn't take any parameters, and one that takes parameters. So what I want to do with that, let's see, we want C++ 11. Can do lambda expression. That's good. I like that. I like that. Basically, what I want to do, I want to be able to pass in a function, maybe. But I need to know how to use it. I think what I want to do is I think I want to void star, not expression. Pretty sure I want a lambda expression. Well, a void star. So what I can do here is do void star mutate function. what that should allow me to do is when I call this from, say, a virus class or something like that, that virus class can have its own built-in function. So, each virus class might have its a list of different things that it can do. So, who knows? It might completely zero out a given category. And what this allows us to do is pass in our private members, such as DNA and behavior. I think. I guess we'll find out later on. So, let's say that just so another thing that we could do, since we're doing this in Qt, is we could connect and disconnect signals and slots, which is one of the big things with Qt that makes it desirable. But I think this actually makes it a little bit easier for me to use. I don't have to connect and then disconnect and then make sure that all those things are done. It's possible that I would consider changing that, though. I'm not really sure. So for now, we'll just use this. I'll assume that it takes a must take DNA. Pointer at argument. Yeah, me too. Right now, basically, all I'm going to get accomplished tonight, especially in the next half hour. Yes, yes, I get it. um, about all that I'm going to accomplish in probably the next half hour is just kind of roughing out um, how I want this thing to look, and hopefully before I stream next time, I'll get the chance to go in here and modify the board a little bit to handle the new cell stuff. So another thing that I might want to do, I might actually want to make an abstract class that would yeah, an abstract class that I could subclass virus, bacteria, and cell off of. That would make it a little bit more portable, I think. It would make it easier to do stuff with, at least. And then I'll probably put... Oh, hi, the wife. Yeah, it would make things a little bit easier to handle in the future, I think. And then I would end up putting factors, DNA, and behavior in probably another header file. Actually, let's do that right now. New header file. Choose. And we'll call this support sure. May need to change the name of that a little bit in the future, but for now it'll work. It'll be better than having all this stuff in there. Okay, so we'll save that and cell. Port.h. Okay, so now let's go to cell and we'll go ahead and change this a little bit so that did I return DNA there? Oh, no. Yes, I do. Of course I do. I'm going to change this to a void function because I don't really need to generate random DNA that way. Void generate and that needs to be a function. Now I need to remember, or Google needs to remember for me, how to generate random numbers. C++ generate random numbers. Actually, I wonder if Qt has that. Not that I don't like the standard library, but if I'm already using Qt, I might as well. Oh, okay. So we need to seed this. Okay, so that's pretty easy. And probably I'm just gonna go to main. Someone can correct me if this is absolutely stupid, but so we'll go ahead and seed this here, and what we can do is, what does this take anyway? Whenever we have a question like this, we Qt US and UN seed. Random number generator. That's a little bit more in depth than I need. So we'll just stick to this and do like, sure, that seems good. Here we'll do yeah, okay, so we kind of think, how do I do? So I know for, well, all these are yeah, all the constituent parts are chars right now. So what I can do is just do I'm trying to think if there's any nifty ways to do this, but I don't know that there is. So we'll just go with underscore DNA dot. We'll just go down the list. Equals qrand. Mod. Just to make sure that I'm not going over our max. That's right. Is that have unsigned char. Uchar? Uchar max. Even better. Max. There may very well be a better way to do this. I could probably cast it to a char pointer and then do some fancy magic there, but I don't know, this seems cleaner and a little bit more clear as to what's going on. Who knows, I might figure out something a little bit better later on. And for right now, size is going to be 1. Because it's one less thing to think about. So all these things are going to be completely random. And same goes for this. Underscore dot. direction. Could I just store this? Yeah, I really could. As in, I could just store it as 1 or 0, 1, 2, or 3, but this seems like a better use of the space we have in a char, I suppose. I don't know. And actually, yeah, I will just need to store it that way. So never mind. That's the absolute wrong way to do that. So instead, we're going to do behavior that direction. Kind of wish I could do. So with the mutate functions, what I'm planning on doing is being completely agnostic to what the types are. So instead of going in and changing values, so that was going to store north, east, south, and west, right? Those are the only directions that it can move in, at least in this system. And what that would have done is when I change a single bit, it wouldn't equal a char, a character later on, at least not north, east, south, or west. So that's most of the reason why that wouldn't have worked in this case. So instead, what we're going to do is we'll just check the lowest bits. We'll check the lowest 4 bits, and if it equals, we'll say if it's the first, like if it's bit 0, then we'll go north. If bit 1 is high, then we'll go east, or whatever, something like that, something on that, in that vein. So actually, probably what I'll do is, so new plan. Direction will be determined when we go to move. It'll be determined by what directions it can go, and then we'll randomize between those directions. So we'll check a set of bits in that, just like we would with the knowledge stuff from before. So like we do with factors, we can do another one here called directions. So that's the plan. We'll check with those, and then that'll make it a little bit more a little bit more open to change, and then that will limit the directions in which the cell can move, instead of saying, oh, this is the direction it will move. Obviously, if only one of those bits is 1, then it will only move in one direction. But if all of the, like, if there's a 15 sitting on the end of direction, then it absolutely will move in, or it could move in any direction, and it'll be randomized. Okay. Okay, so we've got our basic cell. The most basicest of cells. We'll also need to have functions like move, so all of this is going to be turn-based, or at least that's the plan. So each frame there will be, it will essentially go through a linked list of, or just a list of some sort, maybe a vector, I don't know, of all the cells that we have, and they will decide where they want to move. Those will be kept in order of age, so that's another thing that I'm going to need. And we'll make that a long underscore age. Well, I guess lifespan isn't that long, but that's okay. We'll just keep it at that. So age will start out at 0, as one would expect. So we'll set that here, 0. And then each turn, we increment the cell age by 1, and that's how we'll determine whether it's too old or not. We'll go back here, and so what that'll do is we'll compare the ages. Whatever cell is oldest will get to go first, and so that'll, because we will need to process whether things are going to be sitting on top of one another or not. That's just, you don't want two cells sitting on top of each other. Not the way it should work. So, and also it's not very nice. This should actually be yeah. We're going to call that a public slot. All these public slots. Public slot. So what that'll let us do is call these via connections. So the game might have something called, and they don't have to be called that way. They can be called like normal functions as well. But another thing that we can do is, so like for move, we can emit a signal that says everybody move, and then that would allow us to have everybody move. So maybe age isn't taken into consideration here. We just go ahead and connect up all the slots, and whatever order they happen to move in, that's the order they move in. Okay. So we'll have one function called take turn, and this is me just kind of thinking about um, moving towards the uh, abstracted being. Uh, so we're gonna have cell, virus, and bacteria. All of those can work in different ways, and potentially predator. Another one that I want to add over here. Uh, there we go. Yeah, so what that does is it allows us to make an abstract class uh, that we can do this stuff with, and it makes it a lot easier to make connections and stuff, because we know exactly what slots we have, and maybe predators can move in the same way that cells can, and viruses and bacteria can't, and what we can do is just override those. So yeah, that's what it's looking like right now. One thing that we will have to do for sure is when we move, we'll need to set a mutex. And the reason for that is if I would decide to thread the move, that would be one place that we could potentially have race conditions is where is everybody located. So for every move, we're going to check the board and see if the place that we're moving to is occupied currently. Well, if we have these on separate threads, that's going to be a problem, because when we go to move, there could be another person moving, and before we actually set that value, someone else could come in between our calculations and get to that spot, and then we have the exact problem that we're trying to avoid. So what we'll do is we'll set a mutex saying, okay, nobody can touch the board right now. I'm moving myself over there, and that'll make sure that nobody touches the board, at least, and maybe we divide the board up into different areas, and that's the mutex that you would get, is that from that area, and that would keep you from running into people. So yeah, so I'm looking forward to that, hopefully, and maybe we'll need to set one here too, I don't really know. So, basic cell. I think I'm going to call it a night for tonight. But try and get this up onto GitHub in the near future, and I'll somehow put somewhere where that is. I'm pretty excited about this project. Hopefully, I'll be able to come back to this once or twice a week. Probably more towards the one side of the week. So yeah, hope to see a few of you guys later on, and yeah, if you have any questions, I'm still a little bit new to Twitch, but yeah, I'll find a way to post where this stuff is, probably in the channel feed, and hopefully you can look for it there.